Welcome to the module for Outline. You should go to your course pack and fill in the corresponding pages. Conversion factors are fractions that express two equivalent terms. For example, we could write that 1 inch equals 2.54 centimeters, so a proportion could be written. We could write the 1 inch in the numerator, and then in the denominator we could write 2.54 centimeters, or we could flip that and write 2.54 centimeters in the numerator and write 1 inch in the denominator. Which one we choose will depend on what problem we're trying to solve. Let's convert 12 miles to kilometers. Somewhere in your course pack is a list of conversion factors. It may be helpful to have this out while you're looking at this module. We want to start by identifying what our known value is, in this case 12 miles. And then it will also help to identify what unit we would like as our desired answer, in this case kilometers, abbreviated as km. If we look at the chart provided, what we'll find is that 1 mile is equal to 1.61 kilometers. We're going to do a proportion here, and I want to decide where to put the miles and where to put the kilometers. I want the miles to cancel out, so I'm going to put the 1 mile on the bottom. I want the kilometers to be left over, so I'm going to put the 1.61 kilometers on the top of the proportion. When I do that calculation, then the miles will cancel out and I'll be left with kilometers. I'm going to multiply 12 by 1.61. When I do that, my calculator is going to provide me an answer of 19.32 kilometers. I should follow the significant digits rules, and in this case the 12 miles only has 2 significant figures. And so I'm going to write down that my final answer will only have 2 significant figures and will be 19 kilometers. Let's convert 15 pounds to kilograms. Again, let's identify the known value, in this case 15 pounds. Let's identify what unit we would like, in this case kilograms. And then we're going to look at our conversion factor list to find the appropriate conversion. There are different options. In this case, there is a conversion that will lead us there directly. It says that 1 kilogram is equal to 2.20 pounds. So next, I'm going to write a conversion factor as the next step in my problem. I'm going to put the 2.2 pounds in the denominator because the pounds will then cancel out. I'll put the 1 kilogram in the numerator. After canceling out the units, I would divide 2.2 into 15. When I type that into my calculator, I'll get something. I'm going to write down that the final answer is only going to have 2 sig figs, and so I'll write down 6.8 kilograms as my final answer. The International System of Units, also known as the SI system, is a revised metric system. The metric prefixes are used to make large or small numbers more manageable. There is a list of different prefixes that you should memorize. They go from giga all the way to pico. When converting in the metric system, I have a rule of thumb that states that I choose to make this smaller unit a larger number with a positive exponent, and then I set the larger unit as a 1 in the conversion factor. So let's look at the example that asks, what is the conversion factor to convert from meters to millimeters? So what I would do, we're going to write a meter to millimeter conversion. If I look at the metric prefixes, what we're going to notice is that there is a base unit In this case, the base is going to be the meter because the meter doesn't have any prefix written in front of it. That's going to be what I refer to as 10 to the 0 power, which is essentially 1. And then over here is the milli. That's the mm. That's 10 to the negative 3 in our chart. But instead of writing it as 10 to the negative 3, what I'm going to do is I'm going to choose the smaller unit, which in this case is the millimeter, because if you took a meter, there are more millimeters inside of it because they are smaller units. And I'm going to write 10 to some power. And the way that I figure out what power it is I look at how many exponents there are in between these. In this case, I take the absolute value of the difference between these and I find out that there are 3 exponents or 3 spaces in between these, literally from the 10 to the 0 to the 10 to the negative 3. And so instead of writing it as a negative 3, I'm going to write it as a positive 3. And then in front of the larger unit, which is the meter, because it is an actual physical larger unit, I'm going to write a 1. That would be the conversion factor that we would use if I wanted to convert from meters to millimeters. What is the conversion factor to convert from centimeters to kilometers? If I look at centimeters and kilometers on the chart, there is a kilo, which is the symbol K, and that's 10 to the positive 3rd power. I am going to write down the base in the middle, that's the 10 to the 0 power. And then centi is to the right, 10 to the negative 2 power. And so, first again, we need to identify what the smaller unit is and what the larger unit is. The further to the right, the smaller the unit, and so the centi would be the unit that's receiving my 10 to a positive power. The kilometer is the larger unit, and so that's the value that would be receiving just a 1. I then look and see how many spaces there are between the 2 units of interest. In this case, there are 3 spaces to go from kilo to the base, 3 powers, and then there are 2 more powers to go from the base to centi. That's a total of 5 spaces, and so it would be 10 to the 5th centimeters for every 1 kilometer. A wavelength of light is approximately 547 nanometers. What is this length in meters? Let's start by identifying the known value that I want to convert, which is 547 nanometers. And then we'll identify the unit that I desire, in this case meters. I want to write a conversion factor that allows me to go from nanometers to meters. I'm going to put the nanometers on the bottom, and I'll then put the meters on the top. If I look at the list of units, there's the base, which is going to be the meter in this case. That's 10 to the 0 power. And then there's going to be the nano far to the right, which is 10 to the negative 9th. The further to the right that we go, the smaller the unit is. And so the meter is the larger unit, so that's why I'm going to write a 1 in front of it. In front of the nano, I'm going to write a 10 to some power, and it's going to be a positive exponent because of the way that I'm doing it. If I look at how many spaces there are between nano and the base, there are 9 spaces between the nano and the base, and so I'm going to write a 9 there. I then want to figure out how to type this into my calculator. So I could type this in a few different ways. One way is to type in 547, push the division sign in your calculator, type in 10, and then use the caret button to the 9th power. If I do that, that will give me the right answer, which should be 5.47 times 10 to the negative 7th. In some later calculations, it might be helpful to use another method where we type in 1 and then we type the EE button, which is sometimes indicated as EXP or possibly 10 to the X on your calculator. And then we type in a 9. that solves certain issues that may arise later on. And so that will also give you 5.47 times 10 to the negative 7th meters as your unit. The average speed of a hydrogen molecule is 2100 meters per second at room temperature. What is the speed in miles per hour? The first thing we're going to do is identify the known value, which is 2100 meters per second. It may be helpful to write this as a ratio to start the problem. There are 2100 meters in every 1 second of travel. It then can help to identify that the units we desire are miles per hour. We are now switching 2 different units instead of just 1 unit. One thing we can look at is we can find out that 1 hour has 3,600 seconds in it. There are other ways to arrive at that. The other thing that you may find is that 1 mile is equal to 1.61 kilometers, which at first glance might not seem like it's very useful because that's not in meters, but we could then convert the kilometers to meters or meters to kilometers and vice versa. So let's start by converting the length unit, the meters, to miles. And so let's do that to kilometers. Let's put the meter on the bottom and the kilometer on top. The kilometer is the bigger unit because it's further to the left. The base is the meter in this case, which is 10 to the 0. And so there is going to be 10 to the 3 spaces, 10 to the 3rd power difference between these 2 units. That would cancel out the meters. Subsequently, I could convert the kilometers to miles. I would put the 1.61 kilometers in the denominator in the next step. And then in the numerator, in the top, I would put 1 mile. I now have the mile unit that I'm desiring. I don't have the hours though. So now we need to do a separate conversion that doesn't have anything to do with the length and has to do with time. The seconds are in the denominator over here. That's supposed to be seconds, just to make sure we understand that. And so I'm going to write seconds in the numerator so that those do cancel out at some point. And then I'm going to put hours in the denominator so that the hours are the remaining value. So I'm going to write the 1 hour is 3,600 seconds. And so the units there will actually cancel out. When I type that into my calculator, I could type this in as 2100 times 3600 divided by 10 to the 3rd or 1,000 divided by 1.61. When I do that calculation, I get a value of something like 4696 miles per hour. But my original numerical value only had 2 significant figures. Those zeros at the end don't count because there isn't a decimal. And so I would want to round off my final answer to 2 significant figures. So I would write down 4,700 miles per hour as my official answer. Each spring, as the snow starts melting, almost 3,500 cubic feet of water flow over Tequamanon Falls every second. What would that volume be in liters? In this case, we're going to start with the value of 3,500 cubic feet, and we're then going to convert it to liters. I'm going to leave myself a lot of room here because there are a number of conversions that we're going to use. In this kind of problem, there are many different ways to arrive at the final answer, so I'm just going to show you one example. For example, we could convert feet into inches. You might say, why inches? Well, inches will get us closer to centimeters. Centimeters will get us closer to milliliters, and then milliliters will get us closer to liters. That's kind of a path that we could take. So I could use the fact that 1 foot is equal to 12 inches. In order to convert from inches to centimeters, I could use that 1 inch is equal to 2.54 centimeters. I could use the idea that there's 1 centimeter cubed equaling 1 milliliter. I could also use that 1 liter is equal to 1,000 milliliters to arrive at my final value of liters. So what I'm going to do first is I'm going to look and identify the feet here. 1 foot equals 12 inches. I'm going to put 1 foot in the denominator. I'm going to write 12 inches in the numerator. In this type of problem, though, you might notice that there is a cube associated with the foot, but not the cube associated with the foot in the next step, and we need to remedy that. What we're going to do is we're going to cube the whole proportion. I'm going to cube the 12 inches, and I'm going to cube the 1 foot. By doing that, I then have converted it into the appropriate actual volume conversion. I don't have to cube the 3,500 feet because that's already a volume. By doing that, the feet cubed cancel out. I am left now with inches cubed. And so now I'm going to then look and see how can I convert from inches to centimeters. So I'm going to put inches on bottom. I'm going to put centimeters on top. I'm going to write 1 inch is 2.54 centimeters with the 2.54 centimeters in the numerator. Again, I'm going to run in the same issue where one of the values, the inches, is cubed in the previous step, but now it's not. And I'm going to cube the whole value there, everything in that. If this were feet squared at the beginning, I would square everything in subsequent steps that are necessary. That cancels out the inches cubed, and I'm now left with centimeters cubed. I now want to get from centimeters cubed to milliliters. So I'm going to write down that there is 1 centimeter cubed equaling 1 milliliter. That will cancel out the centimeters cubed, and I will end up with milliliters. Finally, I will then convert the milliliters into liters. I will write I'll write milliliters on the bottom, I'll write liters on the top. In this case, the liter is the larger unit, so I do want to put a 1 in front of that. And then the milli, there are 3 spaces between that and the base of liters, and so there would be 1,000 milliliters in that 1 liter. When I type that into my calculator, I would type this in as 3,500 times 12 cubed times 2.54 cubed divided by 1,000. And if it's typed in correctly, I should end up with initially 99,109 liters. But as with other problems, we have to look at how many significant figures are in our original value. There are 2 sig figs in our original value because, again, there's no decimal at the end of this value. It's indicating that the 3,500 cubic feet isn't wildly precise. And so, again, I can't indicate that much precision. I need to then round this off to 2 significant figures and write down 99,000 liters.